Hi learners, welcome back to DHILK. In this video, we are going to discuss one of the most important concepts in amines, the basicity of amines. So, we will understand in detail why amines behaves as bases, and we will also learn how the basicity of amines can be measured using Kb and pKb values. Further, we will compare the basic strength of ammonia and amines and discuss the reason behind it, and then we will move on to an important comparison between alkylamines, arylamines and ammonia to understand which one is more basic and the reason behind their different basic strength. And after that we'll move to the topic amines like aniline are less basic and how the resonance effect influence the basicity of aniline. In addition, we will study the effect of aqueous medium and solvation on the basic strength of primary, secondary and tertiary amines. So these are important topics for you. So we will learn every concept step by step in a simple and logical manner. So watch the full video carefully. If all the concepts cannot be covered comfortably in single session, we may continue in the remaining portion in the next video because I don't want to unnecessarily extend the duration of one lecture. So let's get started. So we can start from the question, why amines are basic? Okay, so we know what is the structure of amines. Amines are the compounds which has nitrogen atom attached to the alkyl groups. So if it is a primary amine, it is RNH2. For secondary amines, R2NH, and for tertiary amine it is R3, and there is no hydrogen atom in tertiary amine. Okay, so for amines, they have nitrogen atom. On that nitrogen atom there is a lone pair available. This is unshared electron, and we know that amines have pyramidal structure, and the nitrogen atom has a lone pair which is unpaired. This lone pair lets them donate electrons to a proton, so they act as a Lewis base. Means that we know what is Lewis bases. Lewis bases are electron donors and Lewis acids electron pair acceptors. So since in amines there are unshared pair of electrons on the nitrogen atom and they can donate electrons to a proton, so they act as a Lewis bases. So look at this. When amines react with the acid, for example hydrogen halides, this is amine reacting with the hydrogen halide, what will happen? The lone pairs will donate the electron pairs to the proton and they will form the salt RNH3X. This is a salt. And to regenerate the free amine, what we can do? We can treat with sodium hydroxide. So amines react with the acids to form ammonium salt. On treatment with a strong base such as sodium hydroxide, the parent amine can be regenerated. Okay. So basically we can say because of the presence of the unshared pair of electrons on the nitrogen atom, amines are basic. Now, amine salts are soluble in water but insoluble in organic solvents like ether. So look at this point. Amines are soluble in water because they can form hydrogen bonds with the water molecules. So there is a possibility of intermolecular hydrogen bonding. So they can be soluble in water but they are insoluble in organic solvents like ether. So for some particular organic compounds, they are insoluble in some organic solvents like ether. So this is the basis for separating amines from non-basic organic compounds. So this we can use for the separation of amines from non-basic organic compounds. This feature we can use. So this is one application. So we discussed why amines are basic. Now we can check how can we measure this basicity. So we use the terms Kb and pKb. What are Kb and pKb? The basic character of amines can be understood using their Kb and pKb values. So what is Kb and pKb? So Kb is known as base dissociation constant and pKb is the negative logarithm of Kb. So we can write pKb is, what is pKb? Is minus log of Kb. And the Kb measures the strength of a base in aqueous solution. So a higher Kb value indicates a stronger base. Higher Kb value, if the Kb value is larger, that means the base is stronger. On the other hand, pKb is the negative logarithm of Kb. So lower Kb value means stronger bases. Therefore, strong bases have high Kb values and low pKb values. Now let us understand how the basicity of amines is measured using Kb and pKb values. Here we are considering the equilibrium of an amine in water. This is amine. Look at this equilibrium amine in water. Amines behave as bases because the nitrogen atom contains a lone pair of electrons. This lone pair can accept a proton from the water. As a result, the amine gets converted into ammonium ion. This is the ammonium ion, and hydroxide ions are produced in the solution. Okay, so amines are reacting with the water and producing the ammonium ion and hydroxide ions. This can be represented using the equation Kb is equal to concentration of ammonium ion into concentration of hydroxide ion by concentration of amines, and pKb is minus log Kb. Now to measure how strongly the amine behaves as a base, we use the base ionization constant called Kb. So this ionization constant, it measures how strongly the amine behaves as a base. Okay. Now a larger Kb value means equilibrium shift towards the product side. So if the Kb value is larger, that means equilibrium shift more towards the product side, producing more hydroxide ion. Therefore the base is stronger. If the more hydroxide ions are produced, then base is stronger. Similarly, we use another term called pKb, which is defined as the negative logarithm of Kb. pKb is equal to minus log Kb. Since pKb is inversely related to Kb, a smaller pKb value indicates a stronger base, while a larger pKb value indicates a weaker base. For example, pKb values of ammonia is 4.75, and for aliphatic amines varies from 3 to 4.22. Since lower pKb corresponds to stronger basicity, aliphatic amines are stronger bases than ammonia. We will discuss this later in detail. And however, aromatic amines like aniline are weaker bases than ammonia, and this is mainly because in aromatic amines the lone pair on nitrogen becomes involved in resonance with the benzene ring, reducing its availability for proton donation. We will discuss these topics in detail in the next sessions. Now I hope you got how can we define the Kb and pKb values in terms of the basicity of amines. So based on the Kb and pKb values, we can predict how strong the base is. Okay. Now we can check alkanamines versus ammonia. Which one is more basic? We already mentioned that aliphatic amines are more basic than ammonia. We will discuss in detail how is the basicity in aqueous solutions. Is it following the same trend? Is there any difference in the trends? And what are the reasons behind this? Okay, we can discuss this in detail in the next session, next video. Okay. So make sure rewatch this video if needed. Practice the concepts. Get fully comfortable before moving on. If you are a class 11 or 12 NCERT student and want complete materials, notes, tips, tricks or live classes, one-on-one sessions, visit our website or contact us through the number. Check the description box or comment section for more details. If you found this helpful, don't forget to like, share and subscribe and turn on the notification bell. Thank you for watching. See you in the next video.